as well. It really does answer the question, are we alone? That to me is a question that transcends science. It's a philosophical, societal, as well as scientific question. To me, that's the big prize. That's why Mars is interesting. That's why human exploration makes sense.
Space programs are often criticized for the huge sums of money they require. Although the American space program is less than 1% of the federal budget, human missions... They have to wait for better times.
There are those who say that we have many problems to deal with here on Earth, and we need to postpone ventures such as human exploration on Mars until these problems are solved. Well, there were many problems in Spain in 1492, and there still are. There are problems that need to be dealt with here on Earth, and should be dealt with. But we also have to think of the future. We also have to think about opening up new volumes of human history. Essential for a positive human future that humanity can get into space. The greatest value that we got out of Apollo was the creation of intellectual capital through the inspiring of millions to go into science and engineering to be part of the great adventure of human expansion to space.
There's a phrase that happened with the Apollo program, which was, if we can go to the moon, we can, and then everybody's filled in whatever they were interested in. Transit, cure cancer, do this, do that. The point is, it did give us a sense that we could accomplish great things. It did bring out the best of us.
We excited a generation of engineers and scientists, a generation that built the computers and cell phones and all the technology everybody uses today and takes for granted.
If we set humans to Mars as our goal, we'll get millions of new scientists that will create new inventions, new industries. This is enormous payback, and we can get it if we set the kind of challenge that will inspire the youth.
To Zubrin, civilizations like people thrive on challenge and decay without it.
We have everything we have today because of our predecessors who had the courage to leave the world of the known and go out to the wilderness and build new cities. And if we stop being people like that, then we will hand down much less to our posterity than our ancestors handed down to us. So there's the choice in life. One either grows or one decays. Grow or die. I think we should grow.
History proves that we have never lost by pressing the limits of our frontier.
In 1989, the first President Bush announced the Space Exploration Initiative, directing NASA to draw up long-term plans to get humans back to the moon and begin developing a program of manned Mars exploration. At Martin Marietta, Zubrin and his colleagues looked forward to moving NASA's space program outwards after 2 decades in low Earth orbit.
Of course, we were very excited when Bush made his call, saying that he was making a national commitment to implement his rule.
NASA assembled a large team to take on the space initiative. In 90 days, the team developed a 30-year plan that required an enormous build-up of space infrastructure.
What the NASA bureaucracy decided to do was basically design the complex mission they possibly could in order to make sure that everyone's pet technology would remain mission critical, which is the exact opposite of the correct way to do engineering.
First, NASA would triple the size of the planned space station and add enormous hangars, as well as free-floating fuel depots, checkout docks, and crew station. Then, they would construct more shipbuilding facilities, bases, and depots. Next, the moon crew would construct the Mars ship, a huge craft dubbed by its detractors as Battlestar Galactica. This ship would carry everything to Mars over an 18-month flight. Once in Mars orbit, a small group would descend to the surface, spend a few days, then plant a flag on the ground and go home. The plan became known as the 90-day report.
To those of us at Martin who had been engaged in designing Mars missions, when we saw the monstrosity, the complexity of the 90-day report, we were dismayed, and it was readily apparent to anyone with any insight that that program would fail politically.
The plan was submitted to Congress. The estimated cost, $450 billion. The legislators wanted to stick a shock. This would have been the single most expensive program for the United States since World War II. By the end of 1990, Congress had refused all requests for SEI funding. When the realization came that the SEI was doomed, Zubrin wrote a memo to his colleagues at Martin Marietta, outlining his problems with the NASA plan and arguing for a more direct approach. Zubrin favored launching a Mars mission directly from the surface of Earth using only existing rocket technology. This negated the need for a lunar base and avoided the complexity and cost of building ships in space. He also objected to NASA's plan for a short surface stay on Mars, a mission that would amount to little more than a flag and footprints exercise. To Zubrin, explore and develop the world. To maximize surface time, Zubrin proposed using a faster flight path, known as a conjunction class mission. This would mean a crew could arrive at Mars during a 6 months journey, then remain on the Martian surface for a year and a half. This would give the team time to explore a wide area and conduct detailed research about the planet. As the Earth returned with no evidence, the crew would launch from Mars on a 6-month trip home. Zubrin was convinced that a simplified, robust, and cost-effective mission could be designed using these principles. Along with several like-minded colleagues, Zubrin decided to ask management at Martin to allow them to design alternative Mars missions.
The management approved it, and we formed a team. It was known as the Scenario Development Team. It was just 12 people from the whole very large Martin company.
One team member, whose thinking was closely aligned with Zubrin's, was David Baker.
I went off to my office and said, all right, how would I do a Mars mission if I had to pay for it and I had to go on the ride? And I said, well, it's going to be simple. There's going to be no on-orbit assembly. I really tried to take everything out of the mission that didn't absolutely need to be there.
While the rest of the team focused on longer-term, more traditional mission plans that required on-orbit assembly, Zubrin and Baker decided to collaborate on a mission that could be done near-term.
We decided to do Mars the way Lewis and Clark did America. Okay? Use local resources, travel light, live off the land.
Zubrin and Baker were convinced that a Mars mission could be launched directly from the ground. The other team members felt this was impossible, but the weight of the rocket fuel required for a round trip to Mars was so enormous it would render the launch ship impossibly heavy. To solve this problem, Zubrin was exploring a radical idea that had been kicked around the aerospace industry since the 1970s. The idea was to produce a methane oxygen rocket fuel directly from the Martian atmosphere. It was a relatively simple and robust chemical engineering procedure that was done commonly in the 1800s, the era of the gaslight. If the idea worked, astronauts could land a relatively light ship with empty tanks. They wouldn't have to ship all with them for their return trip. This would radically lower their size and weight.